Number 15, we have another differentials problem. And we're told that the radius of a sphere is given as 24 centimeters, and its error, the dr, is 0.2 centimeters. So the first question is use differentials to estimate the maximum error in the volume, and then we're going to find the relative and percent errors also. So using differentials to estimate the error in volume means we need a formula for volume. So the volume of a sphere is 4/3 pi r cubed. So if we do the differential of this equation, derive this using differentials, we will be able to plug in values and get our error in volume. So if we take the derivative of this using differentials, we get dv. 4/3 pi is a constant, so we're really just doing the derivative of r cubed. And if we bring down the 3, it would cancel with this 3. So we get 4 pi r squared dr. So by doing the derivative and separating the dv and the dr, we have a differential term, and we can figure this out. So the error in volume is just dv. So we plug in our values. R equals 24. dr is 0.2. We get 4 pi 24 squared times 0.2. So that's going to be a really big number. Let me get the exact value on here real quick. So it's probably, even if you had this on the test, you wouldn't have this big of numbers, but even so, you would never have to put pi into the number. Like, it would always be a number times pi as your answer. So we get 460.8 pi. So that's our maximum error in volume if our radius was 24 centimeters and our error in radius was potentially 0.2 centimeters. So this is saying that if your radius of your ball is 24 centimeters, but it could be off by 0.2, that 0.2 could change the volume by as much as 460.8 pi, which sounds kind of ridiculous, but notice that volume has an r to the 3rd power. So you're involving a pretty big number here. So that's part A, and part B is saying what's the relative error and the percent error. That was part A. So the relative error is a little bit more useful of a term. It's saying how much really is this compared to what the volume actually was. So what you're trying to find when you're doing relative error is you do dv divided by v. You're saying what percent, what fraction of the actual volume of this sphere is this potential error. So you just divide dv and v. Now before you try to plug in r to v and get a big number and plug it in and do this, it's always, always, always going to be better when you're doing relative error problems to put the formulas in first, because a lot of stuff is going to cancel, and then you won't have as big a numbers to work with. So dv, we already have an equation for that right here. So dv is 4 pi r squared dr. V, that's just the volume of the sphere. We have that equation. 4/3 pi r cubed. You can see by writing it like this, we get a lot of stuff to cancel out. 4's cancel out, pi's cancel out. R squared on the numerator and r cubed on the denominator means that cancels out and leaves just one r in the denominator. We're dividing by 3 in the denominator, which actually just sends that up to the numerator. So our relative error boils down to just 3 dr over r. So you can see why I did it this way, because now plugging in r and dr, this is a really easy fraction to do, whereas if you had plugged in all the values for dv and v, you would have got an obnoxious number. So now this is just plugging in dr and r. So dr is 0.2, so 3 times 0.2 is 0.6, and r was 24. 0.6 divided by 24, which is 1/40. So that's the relative error, 1/40. The percentage error is just convert this into a percent. So you would take 1/40, multiply by 100. So that's relative error. Percent error is 100 over 40. 10 over 4. So 10 divided by 4 is 2.5. So there's our relative error, just 1 over 40. Our percentage error, 1 over 40 is 2.5%. So despite our actual error, potential error of the volume being this big of a number, it would really just be changing the volume by a possible 2.5%, which then that might be a more useful topic. So when you're doing error, you can actually find the actual error, just finding the dV or dA or whatever it happens to be. And the relative error is when you compare that, you divide that by the actual number.
The Teaching Center, UF's Learning Resource Center.